Hi, thanks for joining me today. Today we're going to talk about a small part of a much larger idea. And that larger idea is how to solve quadratic equations. And the part we're going to deal with today is solving them with an algebraic method known as factoring. First, let's talk about what factoring is. Factoring is when you have a number or an expression and you know that it can be broken down into smaller parts. It's technically what two numbers multiplied together will give you this number back. In the case of 8, you've got several different factors, 4 times 2, 8 times 1. Its prime factorization looks like this. And so factoring is taking a number or an expression and breaking it down to smaller parts and then multiplying those parts back together to get the original. This is the simple algebra idea, but let's extend that to an algebraic equation. When we're factoring quadratic equations, we like quadratic equations that start with a value of 1. And the standard form of a quadratic equation looks like this. And we're usually looking for the ones that have 1 here, something like it's got a 1, so that tells me already that factoring might be a good tool to use. If it looked like this, it doesn't start with a 1, and that's a pretty good indication that factoring is something I don't want to do. So we don't like this, we do like this. Let's start with an example. An example would be an example would be something like x squared plus 6x plus 8 equals 0. And the way it works is you're looking for the numbers that when multiplied together give you this number and when added together give you this number. And I'll show you in just a minute why it works out that way. Since we are factoring a polynomial of degree 2, chances are we have 2 factors. And so I like to set up a little pattern here with an x and an x, and then I need to find the other terms that go in my factors, and here's how I do it. I create a graphic organizer and I put the last number of my quadratic equation here and the middle coefficient there. And once again, I'm looking for the 2 numbers that when multiplied together give me 8 and when added together give me 6. And I know that the multiples of 8 are 4 and 2 and 8 and 1. So looking at it, when I combine 4 and 2 using addition and subtraction, I can get 6. I can't do anything with 8 and 1 that's going to give me the number 6, so I know that 4 and 2 are what go right here. I know that positive 4 times positive 2 gives me positive 8, and positive 4 plus positive 6 is going to, positive 4 plus positive 2 is going to give me this positive 6. So I can keep these with plus signs. But what we're doing here is factoring. So we're actually, we're solving using factoring. So we factored, now we need to do the solving part. So to solve, I take each one of these terms and I set it equal to 0. And these are just simple algebraic expressions to solve. X equals negative 4 and x equals negative 2. Since I have a degree of 2, I usually have 2 answers, and in this case I do, and we can leave it like that, or we can write another way. We can say that the solution set to this equation is negative 4 and negative 2 using brackets. We're going to do one more example, and then I'm going to prove to you that those in fact are the factors, or those are the solutions to the equation. Let's make it a little bit more difficult. Let's make that a minus. So I do still have the coefficient, leading coefficient of 1, so this tells me that factoring might be a good thing to try. Let's get my little pattern up that I like to use. Make my graphic organizer. We're going to put negative 20 in the bottom and negative 1 on the top. Even though you don't see the 1, it's understood, so the coefficient of this x is negative 1. I'm looking for the two numbers that when multiplied together give me 20, but when added together or combined together, addition or subtraction, give me a negative 1. The factors of 20 I know are 10 and 2, 4 and 5, and 20 and 1. And I can see right away that these factors can combine in such a way, add or subtract, so that I get a negative 1. Let's write those in. But look, I know that I need a negative number because a positive times a negative gives me a negative. So one of these has to be positive and one of these has to be negative. So let's look up here to decide which one. My rule for addition and subtraction is to subtract the numbers and keep the sign of the largest. So we've kept the negative, so the largest number needs to be negative and the smaller number, which is 4, needs to be positive. So let's try it. 4 times a negative 5 does indeed give me a negative 20, and 4 minus 5 does indeed give me a negative 1. So I like what I've come up with. Let's go ahead and solve. Remember, factoring is just the method that we use to solve. So once we factor, we still have to make sure that we take it all the way and find what x does equal. So here I've got x equals negative 4 and a positive 5. Let's come back up here and let's try to prove what it is we're really talking about. Okay, I'm going to go ahead and select the negative 4 and I'm going to substitute it for this x and see if I do indeed come up with a 0 when I substitute and solve. If you've noticed, I use parentheses everywhere I substituted a number. So let's work through that. A negative 4 squared gives me 16. This negative and a negative here are in a multiplying situation, so that negative and a negative give me a positive, and then I subtract 20. So look what I've got here. I've got 16 plus 4, which is 20, minus 20 equals 0. And it's a true statement. We did it right. We can real quickly, let's put 5 in there and do the same thing. This is 25 minus 5, minus 20. And 25 minus 5 is 20. So we do indeed have 20. Goodness. 20 minus 20. And that does give us a 0. So you can see that those indeed are factors. Oh, we did the little proof. Extra steps. One thing about quadratics is it's not always where you want it. Let's erase that. Ooh, I can't. Let's leave it. For example, what if you've got a quadratic that looks like this? In order to factor, we need it set equal to 0, and that's not happening here. But I can use a little bit of algebraic manipulations, and I can subtract the 3x from both sides. And look, x squared and 3x are not like terms. I can't combine them in any way. All I can do is insert this 3x into that expression. And same thing when I deal with the 4. It gives me a 0 pair over here, which is what I'm looking for. But there's not another number on the left-hand side of this equation to combine it with. So all I can do is simply add it to the expression. But now I've got something that I can combine, or I'm sorry, that I can factor. It is set equal to 0. I do have a leading coefficient of 1, and I think factoring might be a good step to try. There are cases, though, where factoring doesn't work, even though it looks like we have an ideal candidate. An example: I start with a 1. I've got it set equal to 0. It looks like I should be able to factor, but let me show you what's going to happen here. Let's make my graphic organizer. We put this last term down here on the bottom and the middle term at the top, and I'm looking for two terms that multiply together to give me 1, but add together to give me 8. And in that situation, we would need the only factors of 1 are 1 and 1. And there's nothing I can do with these, combine them in any way to get 8. And so that tells me that I can't factor. And it's okay to come to this point. It's okay to say, I've done everything right, but I don't have a number that multiplies together to give me -1 or could add together to give me 8. So it's okay to say, factoring is not going to work. I have to try something else. And as always, we have other tools for you. What we're going to talk about in some other videos is how other methods to solve quadratic equations, and those methods are using graphs, using tables, completing the square, or using the quadratic formula. Thanks for joining me. Have a great day.